And now, Tool TV hits the road.
Road trip. Hey, Tool Nuts, we're on a Tool TV road trip. You know where we're headed? Nah, not Graceland. You've probably been there. We're headed to Walnut Ridge, Arkansas. Come on, let's go. We're up the road a piece from Memphis, here in Walnut Ridge, Arkansas.
Hey, are those bullet holes?
More likely drill holes, and that's why we're here. Bosch has one of their premier manufacturing facilities, and we're going to see how the all-new Bosch drill is put together. Come on, let's go.
Hey, two-man, welcome to Bosch country.
Hello, Earl. Welcome to Tool TV. This is Earl Wilson, the plant manager here at the Bosch Walnut Ridge facility. Earl, what goes on here?
Well, two-man, we're the largest employer in this area. We've built over 82 million tools in this facility. Jigsaws, sanders, grinders, drills. By the way, you understand you want to see how we build a Bosch drill?
That's what we're here for. Let's see.
Let's go. These are some of the raw materials that we use to make a Bosch drill.
Oh, I get it. We're going to take round bar steel, flat sheet steel, copper wire, plastic pellets, and magnesium and turn it into this.
You got it. In fact, why don't you go out in the plant now and meet with Mike Purcell, and he'll take you around.
Great. I'm with Mike Purcell, who's in charge of injection molding here at Bosch. How you doing, Mike?
Cool, man. How are you?
Real good.
Great.
Now, Mike, what have I got here? This is raw material, or?
It's plastic pellets that we make our housings for drills and so forth here.
So how do we get from these pellets to this completed housing?
What happens, we buy the pellets from our vendors. It's actually bought in cartons, taken up into the hoppers, dried for a period of time, and then dispersed to the different machines. Throughout the department, we have 23 machines, different colors, red, blue, green, yellow, and so forth.
Depending on what you're running.
All the specifications, right.
All right, well, let's go take a look at the machine.
Sure, thanks. Well, Toolman, you saw the pellets. Now we're going to take the pellets and turn it into a housing. That's where this 390-ton injection molding machine, latest state-of-the-art, comes into play. We bring the pellets in, melt them 550 degrees, inject it into a tool, cure it for a given period of time, kick the part out, we're all done. What we have here is the heartbeat of this machine. It's actually monitoring time, temperature, pressure. It's all preset, predetermined. Gives us a top quality part.
Whoa, that's hot stuff.
Yeah, it is.
Let's take it over to machining.
Sure will. Toolman, this is the machining department. This is where our motor manufacturing actually begins. We take this 12-foot bar stock, cut it to length, knurl the diameter, hob the pinion, and then it goes to the motor line to be assembled into a motor.
All right, let's go over to motor assembly.
Let's go. Okay, Toolman, we've saw the machining of the shaft, we've looked at molding. Now we're going to look at motors. In motors, it takes an armature and a field to make a complete motor assembly. In the armature, we have a steel shaft, the fiberglass tube, and the laminations, as you see here in front of you. From that point, we actually take a commutator, press it on, and wind the copper wire into the slots.
Now, how many feet of wire would there be on an average?
130 to 150 feet, depending on the variation. After we get the copper wire in, we've got the commutator on. We have to turn the comm, fuse the commutator, make the connection, press on the fan, and then balance. You see the balance marked here.
Great.
At that point, we've tested the armature is complete. Now in the field, it's a very similar situation. You have your steel laminations. What we have is a steel laminations welded together, plastic end caps on either side, and paper for insulation. We take this stack and actually wind 2 coils of copper wire and make connections on the end.
Great.
It makes a completed motor.
Hey, Mike, you changed clothes.
Yeah, you're wearing me out, too, man. I had to go clean up.
Looking good. All right, Mike, we got the completed motor and the finished housing. What's next?
Next is assembly. Now, you've seen the automated processes in motors and molding. Now we've got to go to the assembly line. The assembly line.
The good Bosch people come in.
Yes, this is where the Bosch folks are. We've got 8 work cells, 8 operators behind you here. These folks are putting this tool together. There's a lot of components in this tool, therefore we don't automate the process. It's a manual process, but these folks are well trained, they know what they're doing. Okay, this is the reason, this process, this station is the reason we don't automate this product. If you look at this station, it's a very tedious process. It has to be manually done to make sure all the wires are seated properly. The safety is so critical at this point. These wires have to be nested so that you have no short circuits in that tool.
So this is ready for me to test out now and play with, right, Mike?
Well, not quite. We have to test the tool. Let's let this lady do her job. Okay, what we're doing is a high voltage test, a brief visual inspection of the tool, and an amp draw and RPM check.
And what's a high voltage test?
It's a 3,000 volt test to make sure the voltage does not leak when this tool gets out in the field.
Wow, 3,000 volts.
3,000 volts.
All right, now this one's been inspected. Is it ready for me to use?
Not quite. What we have to do is package the product, place them on the skid for shipping, but then we pull a quality audit from each skid of tools, 4 pieces, to make sure that our quality is in the part as we say it is.
Okay, let's go check that out.
Let's do that. Okay, Toolman, what we're doing now is a final audit of the tool. We're double checking to make sure all the accessories are in there, everything fits, amps, RPMs, what you should doing now.
Great. Now where do we do the real world test? Mike, put the tool in action.
We do that in another building.
Let's go.
Toolman, this is our hand-use test area. This is the real-world test of the product where we drill in wood, metal, drive dead screws for a predetermined amount of time so we know the quality of the tool is there.
So when the customer opens the box, it's perfect every time.
It is. It is.
Great. Thanks, Mike. This has been an incredible tour. Thanks, everyone. Now I can finally say what I want to say. Ship 'em! Yeah!